Welcome. This question is a collisions question. It says a 7 kilogram particle with a velocity of +4 meters per second collides inelastically with a 2 kilogram particle that has a velocity of -3 meters per second. After the collision, the 7 kilogram particle has a velocity of 2 meters per second. What is the velocity of the 2 kilogram particle after the collision? So let's visualize. So let's do a before. So before we have a 7 kilogram, and that's moving to the right, and it has a velocity of +4 meters per second. And then here I can imagine a 2 kilogram particle, and this is actually moving to the left, and it has a velocity of -3 meters per second. So these guys are running into each other. There's a heavier, faster particle running into a lighter, slightly slower particle, and they're going to collide. And what happens is we get a collision, and then what it says is that the 7 kilogram particle, well, it moves to the right, and it has a velocity of only +2 meters per second. So that's been slowed. It was 4 and now it's 2. And so the question is, what's happening to this 2 kilogram particle? We're going to call this V. We could call it V2 final if you want, but there's only one unknown here. So let's just call it V. And the principle is that in all collisions, momentum of the system is conserved. So the momentum of the system initially is equal to the momentum of the system finally. And if I want, I can put down m1 times v1 initial, that's momentum of the first particle, plus m2 times v2 initial is equal to m1 times v1 final plus m2 times v2 final. And it's the v2 final. This is the guy that I want to find out. So let's put numbers in. So this is going to be 7 times +4 added to 2 times -3, which equals 7 times +2 added to 2 times v. Well, 7 4s, that's +28 added to, that's -6 is equal to, that's +14 added to, and that's 2v. So if I do a bit of a rearrangement, 2v is equal to +28 added to -6. This was adding, so when we take to the other side, it's going to subtract -14. So 2v is going to be 28 minus 6 means 22. And then -14 is going to be 22, 12, 8. So it's going to be +8. So v is going to equal +8 over 2, which equals +4 meters per second. And the sign is important because it means it's traveling to the right as opposed to traveling to the left, given the way I've defined things traveling to the left as having negative numbers. So it's important to realize that the momentum of an individual particle is not conserved. This particle here starts off with 28 kilogram meters per second momentum, and after the collision it's down to 14 kilogram meters per second. And the other particle, the momentum changed also. what's maintained is that the momentum of the system before the collision is equal to the momentum of the system after the collision. And there we have it.